All right, hello everyone. Just a quick little video detailing some of the work that we did on voting systems and just some of the vocabulary that we used and a couple examples of how this can happen. Okay, so one of the topics that we discussed here, just kind of as an aside, had to do with the idea of a voting system. And we've studied many different kinds of voting systems. We've discovered, let's see, 5 of them. So we know um, the ones that, oops, let's get a ink going here. So we know our basics. We know plurality. We know runoff. We know Borda's head-to-head, and we know an approval voting system. There are plenty of others that combine elements of these and some other unique ways of determining an election. And there's a lot of ways that we can use that don't even have names. We can do something like draw straws even. It would be considered technically a voting system, and so there's a lot of different things. And these ones are the most well-defined ones. And the reason that we use these five here mostly is because they come the closest to being an ideal voting system. Um, so an ideal voting system is one in which we can hope that all candidates are treated fairly, and that there are no surprises, and we have reason to believe that the right person won, um, and that outcomes don't get changed because of events that aren't in the candidate's control. Here's a good example. So this guy, Arrow, comes up with this theorem. And he was looking for, is there a voting system that is ideal? In other words, where candidates, um, the right candidate wins and things that are not in their control um, don't change the outcome. So he was saying that there are four things that have to happen in a ideal voting system. And the first thing was this idea called universal domain. And what it means is that the order on ballot is irrelevant. Okay, so this is a very important one because, and it seems like, you know, kind of duh, right? With a question mark. It seems kind of duh, right? Like you would think that, oh, whether, Biden is listed first or Trump is listed first or whatever candidate, like people are going to vote for them differently. And that's shown to really not be true. We're going to assume that people can at least read their ballot and they know who they're going to vote for going into it. And so assuming that people know that, they're not just going to vote for the first candidate on the ballot. And even if they do, like the percentage of people that would do that is small enough that it won't affect the election. But more than that, this is out of the hands of the people. We don't want an election that's decided in such a way the order of the ballot makes a difference. And you might wonder, well, how can it? That would seem awful to just be like, oh, first place, first position on the ballot gets bonus points. Um, but there are several ways where this can happen, and um, anytime that you have a system, and not just voting systems, but anytime where you have like winner moves on to the next round, that would violate this. So, for example, if you had a system where like candidate A versus B, and then winner faces C in a runoff. Like that would be bad, right? Because if you think about it here, candidate A versus B, in order for either one of them to win the election, they'd have to beat the other and then also beat candidate C in a separate election. Whereas C only has to win once. They'd only have to beat either A or B, but not both. Um, so situations like that just are not very fair systems. So that's why we don't cover any systems that look like that. Okay, so candidate order um, is irrelevant. And if you think about all these setups here, um, when people use a ranked choice ballot, do all of these um, agree with this? Do all those jive? They do, because all we're doing is we're simply counting ballots, and it doesn't matter the order. You know, the winner is the one who gets the most check marks or the most votes. So we don't have to worry about this one. Um, so other than this one strange situation, which, you know, you might do this on the basketball court. Oh, winner plays, oh, want a G2 fight, you know, I'll take on the winner. Like that would violate this. Okay, next one. So Arrow has four different ones. Here's the second one. Pareto optimality. Here's what this one says. It says if A is preferred to B on all ballots, then B cannot win. Okay. Or specifically like B, the election will end up being B over A. Again, this seems like it makes sense. Like if A is preferred to be on all ballots, then there's no way for B to win. And if you think about it, like plurality method, okay. Um, if you think about it, you have candidate A and you have candidate B, and candidate A gets 1, 1, 1, 1, 1, 1, 1, and candidate B gets 2, 2, 2, 2, 2, 2, 2. Okay, and then so clearly A is going to win. I mean, a majority, 100% of the vote, sure. So A is going to definitely win. There's no way for B to win in this case. What about the case of, say, a third candidate? You could have a case where you have this, and then you could have, say, 2, 3, 1, 3, 3, 3, 3. You could have this case here. And again, A is still preferred over B. And again, no matter how many times that you do this, um, you will never have B win the election. Okay. If you were to keep making rows like this with this setup, um, you know, worst case scenario is, you know, C ends up winning and not B. Okay, what about an approval vote? An approval vote, as you know, sometimes has some wonky behavior with it, right? So let's say we have the situation where everybody um, approves of their first and second choice. So everybody approves of their first and second choice. So all of these people, they're going to keep neck and neck. And then is there some way where even though this happens where B is going to get a vote? No, because no matter what place B is, whether it's second, third, or whatever, because in an approval vote, if a person gets an approval vote, no matter what place they are, anybody who's ranked higher than them are going to get approval votes as well. Just because if you approve of your fourth choice, you automatically approve of your first, second, and third choice. That just makes logical sense. So if B gets a check here, A will also get the check. And so again, what winds up happening is you get a tie in this situation. So in an approval vote, it might come out tied, but again, it's stated as B cannot win. So even an approval vote satisfies this. Board account, as you can imagine, clearly satisfies this, just because if you're ranked higher, you get more points, or technically less points the way we do it. Anyway, yeah, so it's perfectly fine that way. All right, let's keep going. What else do we have here? So again, this one's kind of a duh, and we're 2 for 2. All's good as long as A is preferred to B. No way B to win. Okay, Number three, non-dictatorship. Okay, a dictator. Well, what's a dictator? Well, a dictator is someone who dictates the outcome. So a dictator means no single voter determines outcome. Okay, so no single voter determines outcome. Now, in this particular case, we actually do happen to know of an election type that violates this. Um, but only partially violates this. Now, this obviously seems like it makes sense. You don't want a single voter that has like all the power to make all the decisions because then everybody else is worthless, right? This might happen in like, war-torn countries or countries with unstable power, but certainly not in a shining example of democracy, right? Um, so what about the US Senate? Okay. In the US Senate, um, they go to a vote, but generally speaking, the vote is, 100 people, and they vote. If ever it ends up as a 50-50 tie on a particular motion to pass, vice president votes, and he or she will basically, because they cast the deciding vote, they determine the outcome. That only partially happens in this case and violates this. And the reason why it's only partially violates this is because this doesn't happen all the time. The vice president does not always vote, so they really don't have all the power in the system, because they only vote on a tie. Because they only vote on a tie, they only have power in that one situation. Granted, in this Congress, where we have 50 Democrats and 50 Republicans, yes, that's bound to happen a lot more often. But even then, um, if the vote were any other number, then the vice president has no power because they're not voting. Um, so this is a partial um, violation of this. But as far as the other ones go, do we have a case where there's a single voter who determines the outcome? The answer is no, because you may think, again, a tiebreaker vote, but what we're talking about is no single voter determines the outcome at time of voting. In other words, there is no case where a single person goes to the ballot box and believes that, and knows for 100% accuracy that whatever they say goes. That just doesn't happen. Not with any of the voting systems that we have. Okay, so again, we're 3 for 3 on this one. Okay, there's one more to go. I wonder, are we going to go 4 for 4? Independence from irrelevant alternatives. Okay, so this guy Arrow says that we should also have independence from irrelevant alternatives. And what that means is if an election favors A to B, candidate C is entered, then B cannot steal the election. Now, here's the thing. This happens all the time. And it's one of the problems that we have with some of our systems. And so it makes you wonder, in a case where you have candidate A versus candidate B. If the public likes A more than they like B, but candidate C is in the election and steals enough of A's votes, like some people prefer C to A, that there are people that like B. And that what's left over are all the people that like B. Um, in some ways, there's pros and cons to this. And we'll take a look at a situation like this in a second. Um, all five of the ones that we study, this can happen in. And generally, the reason why B steals is because it's a popular second place option. So that's when this occurs. So like if you have candidate A who is very polarizing, he's either loved or hated. Let's say he's, loved by 50% of the population. Um, B is liked by 70% of the population. Um, but then C comes along. All the people that hate A might vote for C instead, or a lot of them, um, forcing B, which is liked by a good chunk of the population, to end up winning. Um, so is that bad? I guess it depends on a lot of factors. And it depends on the individual candidates, the context of whatever election or system that you're running. Um, and some people say it's good and some people say it's bad. Some people say, no, you clearly favor A to B, keep it that way. C is irrelevant. And that's where this term irrelevant comes from, is because C is entered but still never wins. The election changes, but C is never able to win. And so why is C even there in the first place? Um, C exposes the fact that B is a popular second place option or opinion. And that's a very good thing, at least in that regard. So nobody has really, um, forced away from these kinds of elections because of this, but it's not perfectly ideal. But given all of these four techniques, we found, Arrow found that even though this one gets violated with all of our popular elections, this one is the one that you want, that is the least impactful, because at least you can understand where they're coming from with this one. The other ones are kind of unfair. But this one, has some unfairness to it, but not as much as the others. Okay, so let's take a look here. Arrow system states that no voting system based on rankings can satisfy all four of these principles. Therefore, no ideal voting system. Done. Okay, well, we kind of figured that one, right? Well, so much for democracy. Okay, so here's the example. One of the most common types of questions I'm going to ask you here is there an irrelevant alternative? And we're talking a plurality election. So in a plurality election, is there an irrelevant alternative? In other words, is one of these one that isn't winning, but when you remove it, changes the outcome? So let's look at what's going on here. There are 9 voters voting whether to do carpet, tile, or wood in a particular maybe house or something, right? There's 9 voters, okay? And so currently, carpet is winning with 4 votes. Ceramic tile has 2 votes, and wood has 3 votes. Okay, so we're not talking carpet because carpet's already winning. So currently, carpet is winning. But if the question is, if you remove either ceramic tile or wood, would the winner then change to the other? Um, or would carpet still win? So let's say, for example, let's remove wood. If you remove wood and we do a runoff between carpet and tile, who would win? Okay, between carpet and tile, carpet, carpet, tile, carpet, and tile. So in that particular case, 3, 4, 5. So carpet would win 5-4. So carpet is still preferred over tile. Okay, so therefore wood, not right. So let's erase this now, and let's go back and let's look at um, tile. So what happens if we get rid of tile? If we get rid of tile, then it's carpet versus wood. And what happens in that situation? So carpet, carpet, wood, wood, wood. Okay, in this particular situation, wood would win. So what that means here is that tile is that technically the ceramic tile is officially a irrelevant alternative. Um, what's happening here is if you got rid of tile, um, wood would have won the election. Um, and so, but then again, if you think about these numbers here, if you got rid of tile, right? If you get rid of tile and then you change these preference numbers, all of a sudden that would be 2, 3 and 2. This would become now 2 and 1. This would have 2 and 1, and this would be 2 and 1. And so what you're seeing here is that carpet has a majority of 2s, a majority of those second place votes, and that's why this is happening. So when this sort of happens, these irrelevant alternatives tend to bring in very popular second place opinions. Okay, now this doesn't always happen, but it often does in these sorts of elections. Okay, so that's just kind of a illustration there. So what you have to do in this, is there an irrelevant alternative? You just show me like some different combinations and then show me why. Like tile is irrelevant because um, uh, wood wins originally. Okay, so something like that. And so you have to make the description that the winner changes between carpet and wood when tile is either added or taken out. Okay? All right, so that's a kind of a lesson on that, and I will see you soon for the next one.